All right, so let's go over isomers. So isomers are molecules that contain the same number and type of atoms, but arranged in different ways. The existence of isomers is a major reason why there are so many different carbon compounds, and isomers of a compound have the same molecular formula, but can have different physical and chemical properties, and so behave differently. So don't be tricked by molecules where atoms have simply been rotated freely around C to C bonds. These are not isomers. For example, these two images, they're not isomers. Just because these atoms have been rotated doesn't mean it's different. Even though this has been written straight versus being written with a little bend there, it's still 1, 2, 3, 4, 5, 6, 7 in a straight way. It doesn't really matter that it's branched. It hasn't really branched off. It's just drawn differently. It's still heptane, and this is still 1,2-dichloroethane. Now, there's three main types of isomers. There's chain isomers, position isomers, and functional group isomers. So chain isomers are isomers because the chain has actually changed structure. So here we have 1, 2, 3, 4. So I'll actually highlight this and show you guys. So we have 4 in a straight line, whereas here we have 3 in a straight line, and we have a branch that comes out the side. This is a chain isomer. So pentane has 3 chain isomers. It can be either this form, or this form. Position isomers is also pretty easy to point out. So in position isomerism, the basic carbon skeleton remains unchanged, but important groups are moved around on that skeleton. So having a look at this, if I get the highlighter out again, we notice that the bromine has moved from the first carbon to one of the middle carbons. Over here, moved from the first carbon into one of the middle carbons. Now, functional group isomers are very interesting. So if we notice here that we have an aldehyde, so when the C double bonded O is on the end, is an aldehyde, whereas when it's in the middle of the chain between 2 other carbons, it's a ketone. We can also have the same thing happen with hydroxides, with carboxylic acids and esters. So over here we have a carboxylic acid, but if we rearrange it, we can also form an ester bond instead. So this is an example of a functional group isomer. Exactly the same carbons, exactly the same oxygens and hydrogens and the other types of atoms, but they're arranged differently and to give us a different functional group. So examine the following pairs of structures and decide if they're identical isomers or completely different compounds. So for A, the same compound. For B, same compound. For C, they're completely different compounds. This has 2 carbons, this has 3. For this one, believe it or not, this is a functional group isomer because we have the same number of carbons, 1, 2, 3, but this functional group is an alkene, whereas this one is an alkane. All the carbons have single bonds. Over here, they're the exact same. Over here, these ones are also the exact same. They just rotated this a little bit. This one here, this is a position isomer. It's still an amine. It only has nitrogen, but the nitrogen is not on the end. It's in the middle here. Over here, this is the same molecule, just flipped around. This one, 1, 2, 1, 2, also the same thing. 1, 2, 3, 1, 2, 3. So these are functional group isomers. So this is the ester with the hydroxyl side at the end. Let me just check the oxygens. 1, 2, 3. Yeah, and this is a carboxylic acid with a alcohol at the end. If you like this video and want to improve your marks, you should enroll in our online chemistry course. The course has been created by our expert tutors and gives you access to the content from Year 11 and Year 12. The course has a detailed breakdown of each chemistry concept and exam question walkthroughs, perfect for preparing for your exams. Check out the first link in the description and start your free trial today.